that's, we deliver products, but the products we delivered 20 years ago might be very different than the products of today. But it's that social process that we've provided, that infrastructure, that community-driven, consensus-driven framework that allows weaving the best of these various stakeholders, the data that we manage in the web, weaving that together. That's in fact what I think is the most value over the past 20 years. If it was just a product, we wouldn't be here still. And at a certain level, frankly, we just need to recognize that as a community of practitioners, we're way ahead of our time. There's a lot of people basically catching up. But in fact, new norms happen extremely fast. 20 years ago we were talking about and screaming about the value of data, and how data was king, and how data was going to revolutionize everything. And then like a few seconds later, data scientist commands $100,000. You just change your business card, and all of a sudden that becomes sort of a selling point. No one knows what that is, but the fact that this has become so quickly mainstream is actually quite an interesting change. I mean, in the past couple of years, you have seen a huge, huge, huge sea change in terms of the business value of data and the business that are associated with this. And in fact, this is actually a wonderful time for us to sort of rise up at a certain level, because as these new memes are occurring and as these new interests are becoming absolutely clear, and as people start scratching the surface and sort of saying, gosh, I really don't know what a data scientist is. This is actually when they are in fact turning to the data practitioners and professionals, and in fact libraries, to help basically get a sense of what that really, really means. So, from the past perspective, building on our strengths, I'm talking a little bit here on our future, but we've identified at a certain level in the process of what we do, a couple key things that basically I would tease out from looking at the particular conference, and I want to sort of highlight as we look to the future of libraries and the future of Dublin Core. The application profiles work in particular, I think, is going to be critical for Dublin Core to basically step into. And the linked data patterns that provide consistency across cultural heritage institutions is one that I think we're going to have to be very focused on as well. And we have an opportunity to basically bring together the right stakeholders and really sort of own this space in a way that no other institution has been able to step up to. Now, I'm going to bring us to the present and talk a little bit about why I think that's important. All right. So in the context of the present, I'd like to basically talk about the web. I mean, at a certain level, that's a bit old hat. Again, the web has sort of become so much of a commonplace that sort of talking about how cool it is kind of is boring. I mean, I do remember actually talking to a bunch of fourth graders about something completely different. My PhD work is in geography, so I was talking about maps. And one of the teachers basically found out what I did for a day job, and they sort of said, well, tell us a little bit about that. In which that translated into this, would you like to see our fourth grade webpage? Because that was the big thing that they had just figured out doing. They were really excited about this. And it was cool because they were connecting with their webpage with other fourth graders around the world, and it was a really exciting, they were really proud of it, and they should be. I mean, it was a really cool thing. And then one of these girls basically sort of asked, because the girls seem to actually be more inquisitive at that age than boys. Well, maybe forever. But the point is, one of them sort of said, what did your website look like when you were our age? And, and you were just like, well, after I carved it out of stone. But it is. I'm actually really still excited about the web, and there's, I think, strong reasons why. In part because it basically, it serves a very important purpose. I mean, it is the most successful communication platform ever conceived. It has basically provided ways in which those fourth graders could connect with each other in ways that, us working early on in the standards could have never basically comprehended. But the promise of the web, as it increasingly becomes the most pervasive data management and data integration, the way in which we can basically use it to accelerate scholarly communication and learning, decision making, educating the communities around us, sharing data in a web environment to address, extraordinarily, huge problems that any one person or any one organization can't do. Climate change, cancer, AIDS. These are things that we have. With the combination of the web as an architecture and with the combination of people, we can basically live the promise of this web moving forward. And what's happening right now in the very aspect of the current present is the recognition that right now most of the web pages are really in fact designed for people. They're really designed for humans to in fact look at this. And if we look at that as a human, we basically get a lot out of this. But from a machine perspective, machines can't quickly act on this information. What we see in terms of a big bold headline or an italics name, what we see that might be a title or what we know is an author, or we know is a publication date, to a machine is bold, underlined, italics, etc. The meaning that we make isn't conveyed in a way that the applications, the search engines, etc., can pick up on. That is changing. That is changing in a very fast, accelerated way. The new norm is moving from not just a human-readable web, but to a machine-actionable web. Both of these things simultaneously. Our credit card has been doing this for decades. The notion of being able to have something that we, the humans, understand, but in the back of it, it allows us quickly to drain our pocketbooks and wallets and bank accounts faster than we ever thought was possible. Yeah, someone's laughing a little too much there, right? I mean, that's, yeah. My 13-year-old and Xbox is a great example of this. And underpinning, all of that are low-level standards and technologies that are horribly named. And in part, I'm sorry for that. But this is about making the data web possible and making these smaller atomic building blocks of data possible, so that we can begin to snap together these actionable data that we combine from different parts of the web and create something greater than the sum of their parts. The little RDF logo, from a standpoint of a child's toy, is actually quite appropriate in the terms that the child's toy has engineering tolerances of that of an internal combustion engine. That's what makes those little satisfying clicks when you snap them together. And in fact, the RDF, or the Legos from 50 years ago, actually snap together with the Legos of today, because even though they've been packaged in different ways for different price points, and now completely owned by different brands that are trying to sort of move these into the Star Wars themes, or the Knights of the Round Table themes, or the Jacques Cousteau themes for different audiences all over the world, they still basically follow those same engineering tolerances and those same principles that allow them to be combined and snapped together. And this provides a basis for that both human readable and machine actionable web. And a lot of the underlying standards and technologies that this group has developed early on in Dublin Core went into the development of these particular things. And it was in part also taking advantage again of the lessons that we've learned here from the web. Not just making data more actionable, but empowering people to actually do interesting things with this data. I'm going to go ahead of myself here. So I think everyone's basically heard the CAPTCHA story. Everyone knows what the CAPTCHA, yeah, everyone really. ReCAPTCHA, yes? The notion here that in short, together by basically not only sort of indicating to a machine that we are in fact human and not a machine, we can actually type in the words that we see and together translate large corpuses of information. So our cultural heritage information, in essence, of developing countries is still in print. We can do bounding boxes around those words. Those bounding boxes get shipped into ReCAPTCHA. We type those in, and collectively we are translating all of these scanned images of our cultural heritage. And that data is being increasingly made available to everyone. But it's this notion of doing small things as humans, but in a way that gets combined together, that reconstructs the entire New York Times archive in 8 months, and all thanks to you. The notion of being able to take these small building blocks and the power of people to create new and interesting things is a very powerful one. These two individuals clearly have more time on their hands than they should, but the point is the fact of reassembling and creating these new interesting shapes from these small atomic building blocks in essence, is what linked data is about. So all these underlying standards and technologies to make the web more machine actionable is really about creating a framework for sharing and connecting the data using the web as a platform. Now, in the context of that story, I'd like to talk about a tale of two webs, because this is what I believe is happening right now. This is the visible web. For the most part, I'm going to reduce the visible web into two images. Both of these services are built, in essence, from you. I'm going to break one down and try to, we throw words around here quite frequently. We do this in Dublin Core. We do it, as humans. I'd like to basically break the difference down between search and discover. So search is an example on the Google side. You type something in and you get something back. And there's been a lot of advances in search, and we're going to talk about some of them today, and you're going to hear a lot of them over the next couple days. There's actually been a lot of advances on discovery. Facebook's an example of this. One, you're basically gathering up all the web, typing things in, trying to find out what you can find in terms of search engines. The other, Facebook, is actually, you recognize there's a lot of things going on out there at once. There's huge amounts of information. But the only things that I'm going to be paying attention to are those that I've basically chosen that I trust. So of the wide range of things that are going on, I'm only going to be seeing things that, in fact, are available through my friends, or my family, or folks that I work with, or folks that I collaborate with in various projects. I've segmented the web and all of the things that are going on to basically just to a stream of information that is filtered through a trusted lens that I've created. Again, both of these systems basically are predicated on exactly the same architecture. Both of these systems are incredibly helpful in terms of disseminating and sharing information. But both of these systems do this, again, from a slightly different approach, all based on the same information and architecture. I can type in the phrase Albert Einstein, a string. On the left-hand side, I get a tremendous amount of information back relative to things that are most popular about that string. On the right-hand side, I've got an information in which data from lots of different sources has been aggregated to give me information about one particular interpretation of that string as a person. So on the left-hand side is the traditional kind of search results. On the right-hand side is, in essence, what Google calls a global knowledge graph, which was built off of, a few years ago, an acquisition from MetaWeb and Freebase. In essence, a big RDF storage layer that allowed different information to be aggregated together, and in a pretty cool and interesting way. This is a very interesting power of using the web as a search paradigm. And in fact, you're going to hear in the next couple days, if you haven't already, of some great work that Google, Bing, Yandex, Yahoo, and a few other folks have come together to say, this is how we're going to actually take some of those early standards, mark them up in a web page, and improve those search results, which is awesome. And I want to basically bookmark just how important that is as we start moving forward. I'm going to flip back here to Facebook for a second. In particular, I'm frankly, just to be clear, not a huge fan of Facebook. But what I am actually a fan of is big, large graphs of data. And if anyone has actually played with the graph search aspect of Facebook, this is a great example of what can happen with big graphs of data. Just quickly, has graph search shown up? People play with this yet? Yeah, oh come on, you have to have played with this more. It's actually both cool and scary at the same time. All right, but here, let me just sort of quickly go through this. Find me all my friends that like Albert Einstein. Find me people that like Albert Einstein near me. Find people that know something about physics, which is inferred by basically liking Albert Einstein. There is no set number of queries that we can basically put inside of the graph search. It, in fact, builds off of how we start linking to different resources. By saying that you live at a particular place, it can basically figure out what it means by near me. By choosing an IP address of where you're doing, it actually knows what you're near. I can actually type in, find me people that like Albert Einstein near me, and it picks up all the people here in Texas. This is what happens when we start creating graphs of data and start basically putting in places really interesting open search capabilities to explore this. It opens up new ways in which, in fact, discovery and search can coexist. And in fact, it's a continuum between discovery and search. But the thing that is common among all of this